Hi everyone, welcome to My Max Academy. In this video, we'll continue with the chapter Relations and Functions, which is chapter 1 from 12th standard CBSE Mathematics. We'll continue from example 13 in page number 10 in your textbook. So what is given is f is a function from set 1, 2, 3 to 1, 2, 3 and f is an onto function. F is an onto function. What we have to prove is we have to prove that f is 1 to 1. Right? Example 13 says show that an onto function f from 1 to 3 to 1 to 3 is always 1 to 1. So it is given that f is a function from this set to this set and f is onto. So these two are given. We have to prove that f is 1 to 1 function. So proof is we have to prove that f is 1 to 1. So we'll assume that suppose if f is not 1 to 1. Suppose f is not 1 to 1, not 1 to 1, 1 to 1 function, then what does it mean? If it is not 1 to 1, then suppose f is not 1 to 1 function, then two elements say element 1 and element 2, 1 comma 2, suppose if we call this set as A and this set as B, right? Suppose f is not 1 to 1 function, then two elements say f1 comma 1 comma 2 belonging to A will have same image, which means two elements will go to only one element in set B. Suppose if f is a function, so this is your A set, this is your B set, and f is a function 1, 2, 3, this is 1, 2, 3. Right? So this is 1, 2, 3 is this set, and this 1, 2, 3 is this set. Suppose if f is not 1 to 1, which means at least two elements, then two elements say 1 and 2, you can take any two elements, I am taking 1 and 2, both 1 and 2 will go to the same element, say 1, or both can go to 2. So both two different elements will have say 1 comma 2 belonging to A, which means element 1 and 2, I can say element 1 and 2, 1 and 2, element 1 and 2 belonging to A will have same image, right? So which means it will have, both elements will have only one image, right? Also the element 3 belonging to A, I am calling this set as A, this set as B. Also element 3 belonging to A will have only one image, because f is a function. So 3 can go to only one number. So it can either go to 2 or it can either go to 3. It can either, suppose if it is going to 2. The 3 can go to 3 also, but it can go to only one element because it's a function. Every element should have a unique image. So the 3 cannot go to two different numbers. So which makes our codomain elements, which are 1, 2, 3, right? The range will have at most two elements, 1 and 2. Range is what? All the mapped elements, right? So therefore right? So therefore the range of f will have at most means maximum two elements, right? Therefore the range f will have at most two elements, which means here the range can be 1 and 2. The set of all mapped, what is range? Range is set of all mapped elements, and this B is called as codomain, A is domain, B is codomain, and the range is 1 comma 2, right? The range will have at most two elements, right? So this implies range is not equal to codomain. Range is not equal to codomain because codomain set has three elements. Codomain is this set. This has three elements, but range has only two elements. range is what? 1 comma 2. Your range for this, suppose, will have maximum 1 comma 2. It can be 1 comma 2 or it can be 1 comma 3, anything, but it will have maximum 2 elements. Suppose if both 1 and 2 go to 1 and 3 goes to 2, then the range will be 1 comma 2. Or we can take these two, both 2 elements go to 2, and suppose 3 goes to 3, then the range will be 2 comma 3. Right? So which means the range is not equal to government. This implies f is not onto. F is not an onto function, which is a contradiction. Which is a contradiction because it is given that this is a contradiction because it is given that f is onto, but we are getting f is not onto. It's a contradiction. Therefore, our assumption is wrong. Therefore, f is not an onto function is incorrect. Therefore, f is not one-to-one function is incorrect. Therefore, f is an one-to-one function. F is an one-to-one function. So this is how we prove that if f is a function from this set 1 to 3 to the other set 1 to 3, and if f is onto, then f must be 1 to 1. F must be 1 to 1. Now we'll move on to example 14. Example 14 is, it is given that again f is a function from 1 2 3 to 1 2 3. So what is given in the question is f is a function from set 1 2 3 to set 1 2 3, and such that f is 1 to 1. F is a 1 to 1 function. What we have to prove? We have to prove f is onto. F is an onto function. We have to prove that f is an onto function. So f is a function from same set 1 2 3 to 1 2 3, and we have to prove that f is an onto function, but it is given that f is 1 to 1. F is 1 to 1, we should show that f is an onto function. So to show f is an onto function, we should show that every element in this set should have is an image of some element in this set. Then we prove that f is onto. Now a proof is very obvious or straightforward proof. F is 1 to 1, right? F is 1 to 1 given. F is 1 to 1. So every element, or we can say f is 1 to 1. So we can say all the three elements, f is 1 to 1. So all three elements in this set 1 2 3, all three elements must be mapped to mapped mapped to, sorry, my handwriting is not so great, or it is really bad. Must be mapped to three different elements in B. So three elements in A, in set A must be, so all three elements in A, set A, if I call this as set A and this is set B, must be mapped to three different elements in B, right? So therefore I am writing the continuation here. So therefore range will have three elements. So this implies range is equal to codomain. When range and codomain are equal means it is an onto function, which means every element here is an image of some element here. Every element is an image of some element, right? So range is equal to codomain. Therefore, f is onto function. F is an onto function. For example, if I try to draw the same diagram, suppose the arrow diagrams, this is A, this is B. Suppose 1, 2, 3, 1, 2, 3. This is A set, this is B set. Suppose F is given as 1 to 1, which means 3 elements in A should be mapped to 3 different elements in B, because it's a 1 to 1 function. So which means 1 can go to 2, 2 can go to 3, then 3 can go to 1. Or anyway, or 1 can go to 1, 2 can go to 2, 3 can go to 3. Ultimately, 3 different elements here should go to 3 should be mapped to 3 different elements in B. Which means your range is what? Set of all mapped elements in B. The range will have 3 elements, and that is also equal to the codomain B. Codomain is also having 3 elements, range is also having 3 elements, which means codomain is equal to range. Therefore, f is an onto function. Fine. So all of you can take notes. Yeah, I'll move on to the next problem. We'll start with exercise 1.2. I'm erasing this. So exercise 1.2, first problem. So first problem is, what is given is, show that the function f from r star to r star. So f is a function. So given is f is a function from r star to r star. F is a function from r star to r star defined by, f is defined by f of x, defined by f of x is equal to 1 by x. And what is r star? R star is set of all non-zero real numbers. R star is set of all non-zero real numbers, which means it has all real numbers except 0. In other words, you can say your r star is equal to r star is equal to the set R minus the singleton 0 except 0. All the elements in R except 0, that is called as r star. That's how they have given. And what else is given? We have to show that there are 2 parts to this. We'll do the first part here. The first one is 1 to 1 and onto. We have to show that it is 1 to 1 and onto. So what we have to prove? To prove is f is 1 to 1, first part, and second what we have to prove is f is onto. F is onto, which means f is an onto function. And there is second part, which is the result true if the domain R is replaced by n with codomain being the same? That we'll do the second part. We will do this first, this one, right? So the proof is that we have to show that it is 1 to 1. So proof. Now how do we show f is 1 to 1? Whenever we have to show f is 1 to 1, we'll take 2 elements from the domain R star such that f of x1 equal to f of x2. So whenever we have to prove f is 1 to 1, we should take 2 elements. Let x1 comma x2, I'm taking 2 different 2 elements into x1 comma x2 belonging to R star. There is this R star, which is the domain belongs to R star, such that f of x1 equal to f of x2. So we have taken 2 elements, x1 comma x2 belonging to R star. R star is nothing but set of all non-zero real numbers, set of all non-zero, fine, non-zero real numbers. Now such that f of x1 equal to f of x2. Now we should prove that x1 equal to x2. If you prove x1 equal to x2, then it becomes 1 to 1. See, just to understand how this function is, just for our understanding we can draw this. Suppose this is your R star. Again this is your R star, which means all the real numbers except 0. So 1, 2, 3, minus 1 by 2, all root 2, root 3, everything. 1, 2, 3, 1 by 2, 1 by 3, 1 by 4. All the real numbers except 0. So 1 will go to, f of 1 is 1 by 1, which is 1. 1 will go to 1. 2, f of 2 will go to 1 by 2. F of x is 1 by x means 2. If I substitute 2 here, then f of 2 will go to 1 by 2. F of 3 will go to 1 by 3. Right? So minus 1 by 2 will go to minus 2. Because f of, what is f of minus 1 by 2? Write it here. Suppose f of minus 1 by 2 will be equal to 1 by minus 1 by 2. Because f of x is 1 by x. So that becomes minus 2. So your f of minus 1 by 2 will go to this. Again root 2 will go to 1 by root 2. 1 by root 2. Root 3 will go to 1 by root 3. So this is how the mapping is. This is how the function is. Fine. Now see, looking at the arrow diagram looks like it is 1 to 1, but we have to prove this mathematically. So we have taken two elements x1, x2 belong to R star, such that f of x1 equal to x2. We have to prove x1 equal to x2. Now what is f of x1? Definition, f of x is 1 by x, so f of x1 will be 1 by x1 equal to f of x2 will be 1 by x2. Right, now cross multiply. 1 into x2 is x2 equal to x1 into 1 is x1. So you get x1 equal to x2. So we started with f of x1 equal to f of x2 and we got x1 equal to x2. Which means when the images are same, then that elements have to be same. Suppose if you get x1 is not equal to x2, then it becomes many to one. Right? If you get x1 is not equal to x2 means two different elements are having the same image. F of x1 means image of x1. F of x2 is image of x2. When two elements have the same image, we have to prove that those two elements are same. Then it becomes 1 to 1. So therefore, f is 1 to 1. So we have proved f is 1 to 1. Now we should prove that f is onto. F is an onto function. Now onto function, how do we prove? So for onto function, we should take an element in this set codomain and we should show that any element that is taken is an image of some element in this set. If any element that or every element here should be an image of some element in here, in the domain. So if you show that, then it becomes onto. So for onto, the proof will be, for onto, this is a proof for 1 to 1. 1 to 1, this is a proof. Onto is, we'll start with taking element from this R star. So we'll say let y belongs to R star, and that R star is what? It's a codomain. We are taking an element from codomain. Right? Then we should be able to find some x in this such that f of x is equal to this. So I took an element y from this set. Right? So these will have x. And these are f of x. F of x means y. F of x means the elements are denoted by y. Y is equal to f of x. So if I take an element y, then I should be able to find an x in this set such that f of x should be y. So y should be an image of some element in the domain A. Then it becomes onto. So now I am taking an element y from this set R star. Right? Then whenever we have to prove onto, we will prove this. We will say f of x is equal to y. And what is f of x? F of x is, or we will say y equal to f of x, and y is equal to f of x is 1 by x. You can do this in the rough work, and we have to get x in terms of y. So x will become 1 by y. Right? If y equal to 1 by x means x is 1 by y. Then we will say, and clearly this 1 by y, this 1 by y is also a real number. It will belong to R star. So for a y belonging to R star, there exists that y belongs to R star, or we'll say for every y, for every y belonging to R star, there exists x equal to, which is x is equal to 1 by y. So this you have to do it in the rough work. You have to put y is equal to f of x and put f of x is 1 by x. This is the definition of the function. Then y is equal to 1 by x, then write x in terms of y. which means you are right here we have y equal to 1 by x. You should write it as x equal to something of y. Here you should have only x, here you should have only y, right? So then there exists x is equal to 1 by y, such that 1 by y that belongs to R star. And that R star is what? It's a domain. That element should be in R star. For every y, the x should be in this set. For every y, if you are able to find an element x in this set, I can also put the element x inside this. For every y, I should be able to find an x such that f of x should be equal to y. Then that makes f as onto. So for every y belonging to R star codomain from here, there exists an x equal to x should be what? X should be like 1 by y. How did we get x is equal to 1 by y? From this rough work. Belonging to R star. So this x should belong to domain such that now we should find what is f of such that what is f of x? F of x is equal to f of x is 1 by y. So f of 1 by y. We have to show f of x equal to y. So that is equal to what is f of 1 by y? F of x is 1 by x. So f of 1 by y means 1 by 1 by y. So f of this is your x. F of x is 1 by x. So what is 1 by 1 by y? That is y. So we have proved f of x is equal to y. Such that f of x is equal to y. Therefore, f is an onto function. Or if f is onto, we can say. So we have proved f is 1 to 1 and we have proved f is onto. Fine. So all of you can take the notes. Now we will prove the second part of this. The second part of the question is, so what is given? Second part of the question is, I am erasing this. So given is, suppose if the domain is replaced by n. The second part of the question is, suppose if f is from n to R star. N is a set of all natural numbers. The same definition, f of x is 1 by x and your R star is set of all non-zero real numbers. R star is r minus 0. N is a natural number. What is n? N is set of all natural numbers. Set of all natural numbers. We should check. We are not going to prove here. We have to check if f is 1 to 1, if f is onto. So check means it may be 1 to 1, it may be not 1 to 1. We don't know. Fine. So suppose if the domain, which is n, it was all star, we replaced it with n. So that's what the question says. The second part of the question is the result true if the domain R is replaced by n and the codomain being the same as R star. So codomain is same, but instead of here domain it was R star. If we replace the domain with n, set of all natural numbers, is the result still true? Which means can we say f is 1 to 1 and f is onto? We have to check whether it is true. So now to check 1 to 1 again, if you see the set for this one, how the arrow diagram will look like. See, suppose this is your n natural numbers and this is your R star. Set of all. Now this will have 1, 2, 3, 4, etc. It will not have 1 by 2, 1 by 3 and all because it is all natural numbers. So this is all weird numbers except 0. So which means it will have 1, 2, minus 1 by 2, 1 by 2, 3 by 1 by 3, all that 1 by 4, 1 by 5, etc. Root 2, root 3, all the real numbers except 0. Now what is f of 1? 1 will be mapped to 1. F of 1 is 1 by 1. This is your function f. Right? So 1 will go to 1 by 1, which is 1. Then 2. F of 2 will go to 1 by 2. So 2 will go to 1 by 2. So 1 by 2 is where? This is 1 by 2. So 2 will go to 1 by 2. 3 will go to 1 by 3. 4 will go to 1 by 4. 5, there is a 5. 5 will go to 1 by 5. Right? 6 means 6 will go to 1 by 6. Right? But looking at the arrow diagram, it looks like it is 1 to 1. So we will try to prove that it is 1 to 1. So to prove 1 to 1, the same proof. We'll take two elements x1, x2 belonging to n, which is our domain, such that the images was f of x1 equal to f of x2. Images are same. When images are same, we have to prove the numbers are also same. We have to prove x1 equal to x2. So prove x1 equal to x2, then f is 1 to 1. If x1 is not equal to x2, then f is not 1 to 1. So now what is f of x1? 1 by x, which means f of x1 will be 1 by x1 equal to 1 by x2. Again, if you cross multiply, you will get x1 x2 equal to x1, which means x1 equal to x2, right? So therefore that makes it f is 1 to 1. So f is 1 to 1. So we have proved f is 1 to 1. So even if you replace the domain with n natural numbers, it is 1 to 1. So we have proved that it is 1 to 1. We have proved that it is 1 to 1. Now we should check whether it is onto. Now clearly is it onto? For example, 2. If we keep mapping 2, so which element will go to 2? Here. Suppose if I take the element 2, which element will go to 2? Which so 2 can be image of what? So 2 is here. 2 can be an image of which number here? Which means f of x, can it become 2? F of x, can it become 2? Which means I should find some number here, so that f of that number should give me 2. Which number will go to 2? Only this. Suppose if I find f of 1 by 2, what is f of 1 by 2? Just try to find f of 1 by 2 from this. F of 1 by 2 is 1 by x. 1 by 1 by 2, which gives me 2. F of 1 by 2 is 2. F of 2 is 1 by 2. F of 1 by 2 is 2, but which means my x should be equal to 1 by 2. But that 1 by 2, it is not in this set. X should be in this set, but this 1 by 2 is not there because 1 by 2 is not a natural number. Which means if I take an element 2, you cannot find any element in n such that f of that element should be equal to 2. And f of that element will be 1 by 2. F of 1 by 2 will map to 2. 1 by 2 will go to 2, but 1 by 2 is not in this set. Right? This 1 by 2 also should be in this set. If that 1 by 2 is in this set, and for every element you are able to find an element here such that f of this element is equal to 2 or 3 or whatever, then we can say it is onto. But so here it is not onto because this element is not an image of any of the elements here. Because this element, I can get the element as 2 or f of x as 2 only when I have 1 by 2 here. But 1 by 2 is not a natural number. Similarly, 3 also does not have. For 3 can be an image. 3 is an image of 1 by 3, but 1 by 3 is not here. So which means 3 cannot be image of any element in this set n natural numbers. So it is not onto. It is 1 to 1, but it is not onto. So to disprove that it is, or to show that it is not onto, or disprove that it is not onto, to show that f is not an onto function, we will take one element from here. We can take 2 itself, such that we will show that there is no x in this, such that f of x is 2. Therefore, f is not onto. Even if we can find one element which is not an image of any of the elements here, that will make f as not onto. Which means because for onto every element here, we should be able to find an element in this set, such that f of that element should be equal to 2. Right? So here it is not onto. So once you draw this diagram, you will get some idea whether it is 1 to 1 or onto. But we can't go with the arrow diagram saying that we cannot say that looking at the diagram it looks onto, so it is, or looking at the diagram it is not onto, therefore f is not onto. We can say that way. We have to write a proof, or we have to give an example where it fits. So to prove f is not onto, or to show f is not onto, we'll take one element. So we'll say 2 belongs to R star. Here R star means it is understood that it is domain R star, but there does not exist any x belonging to n in this, which means in this set, such that my f of x should be equal to 2. Therefore f is not onto. F is not an onto function. F is a 1 to 1 function, but f is not an onto function. Fine. So so this is how we show that f is 1 to 1, but f is not Ex-1.2. So all of you can stop the video and take the notes. I will stop the video here. You can watch my next video for the continuation of this. Thank you for watching. See you in the next video. Thank you.